All right, so we're back. We had left off where we needed two equations here because we have two unknowns. We don't know the velocity of either object after the collision. So we have one equation here based upon the kinetic energy and one equation here based upon the momentum. So the kinetic energy equation, well, we know what kinetic energy is. So I'm going to flip sides on it. I'm going to put the 0.6 times the initial kinetic energy is equal to the final kinetic energy. So that's 0.6 times 1/2 mass of the 5 times the speed of the 5 squared plus 1/2 mass of the 8 times the speed of the 8 squared is equal to the initial is equal to 1/2 times mass of the 5 times the speed of the 5 afterwards, which we're establishing as c. So 1/2 c squared plus 1/2 mass of 8 times d squared. Now we do know these numbers over here. We actually did calculate this right here as, see if I can see it in the board here, is at 86.5 joules. And so this is 0.6 times 86.5, which is 0.6, 86.5. Oops, mistake there. So 86.5, enter 0.6 times. So 51.9 joules, that's the total kinetic energy afterwards because we lost 40% of it, is equal to 1/2 mass of 5 c squared plus 1/2 mass of 8 d squared. Now I'm going to need some room here, and so I'm going to erase some of this stuff and just, it's now a math problem. So you know the formula for kinetic energy, I don't need that anymore. So I have one of my equations here, -17 is equal to 5c plus 8d. And the other equation, I'm going to multiply everything by 2 here, just to get rid of my 1/2. So times 2. And so on the left-hand side, I get, you know what, just in case I do not want to make a careless error here, so 103.8. So I have 103.8 is equal to 5c squared plus 8d squared. 5 being the mass of the 5 kilogram mass and 8 being m sub 8 over there. So we don't need this stuff right here anymore. And I definitely will need room. Now to solve a problem like this, I have two equations, two unknowns. Solving simultaneously doesn't really work particularly well because I have squares in here. And that really makes solving this a pain in the butt. However, what I'm going to do is I'm going to solve for one of these variables and then plug into the one below it. So to do that, I'm going to grab this marker. To do that, I'm going to solve for c just because dividing by 5 it gets slightly nicer numbers than dividing by 8. And so I have -17 minus 8d is equal to 5c by just getting the 8d over to the other side. And then I divide by 5. And so what I'm left with here is c is equal to -17/5 minus 8/5 d. You are dividing both of these terms by 5. And this ends up being, this is -3.4 minus 1.6 d. With that, I plug into the second equation. So this is 103.8 is equal to 5 times, I take that value over there, -3.4 minus 1.6 d squared. So that is what c equals, plus 8d squared. I am multiplying a binomial here. Notice that the negative sign, I can factor the negative out, but I'm still squaring it. And so this is equal to 5 times 3.4 plus 1.6d squared plus 8d squared. Just because the negative sign there does not, when I square it, the negative sign goes away. So this is 5 times, let's see, so it's a side note over here. When I'm squaring a binomial, I have a plus b squared is a squared plus 2ab plus b squared. If you've forgotten that, check your algebra notes or your algebra textbook. or go online, it's going to be many places there. A minus b squared is a squared minus 2ab plus b squared. That's a plus sign there. So this is what I'm doing over here. So I have 3.4 squared. So this is 11.56 plus 3.4, 1.6 times, 2 times 10.88d plus 1.6 squared. 1.6 squared is 2.56d squared plus 8d squared. And so multiplying out the binomial, that's this right here. This is a squared plus 2ab plus b squared. Then I distribute the 5 because I have this 5 out front, so I multiply that times each of the things inside the parentheses. So 11.56 enter 5 times, and I get 57.8. That's 103.8. On the left-hand side, 57.8 plus, and then I have 10.88 times 5, 54.4d plus, and then 2.56 times 5, 12.8d squared plus 8d squared. So distributing the 5 gets me this information right here. It is a quadratic equation here, so I need to use probably the simplest thing. If I can't factor it, just use the quadratic formula, which probably with decimals, I'm going to use the quadratic formula. And so what I need to do is combine like terms and get everything on one side of the equation. And so I'm going to take this, get everything on the right-hand side. So 0 equals, I have my 2d squared terms right there. So that is 20.8d squared. Plus, I have my d term here, 54.4d plus, well, when I subtract 103.8 from both sides, so 57.8, 103.8 minus, I get negative minus 46. And so d is equal to negative 54.4 plus or minus the square root of 54.4 squared minus 4 times a times c, negative 46, divided by 2a, 20.8. I'm going to have two solutions. Now, two solutions, I cannot immediately eliminate which one is the wrong answer or which one is the right answer. At least I don't want to yet. There's some major clues here about which one is correct and which one is not, but you can't look at the numbers immediately and just go, oh, that can't be it. Let's go through my discriminant here, 54.4 squared, and then I have 4 times 20.8, and then 46, that is a 46, let's just double check out 46. So this becomes the square root of 2959.36 plus 3827.2, which is the square root of 6786.56, and then square root, we get 82.38. And so I have negative 54.4 plus or minus 82.38 divided by twice that, which is 41.6. And so I'm going to get two answers as mentioned earlier. I have the plus solution and the negative solution. So if I do the 41 points, let's see. So just so I don't get confused with my calculator, 54.4 negative, enter. 82.3 minus, and then 41.6 divided by, I get negative 3.286, that's meters per second, or 54.4 negative, enter, 82.38 plus 41.6 divided by, or 0.626, actually let's go to another decimal point there, meters per second. All right, So I have my two answers here. I do have a formula for C right here. And so I can just plug straight into that formula to get my values for C. So if that's my values for D, my values for C, plug it into that formula. So I take the second one, 1.6 times negative, and then 3.4 minus. So this would be negative 4.476 meters per second. And then if I did this one, 1.6, enter 3.2861 times the negative makes it a positive, and then 3.4 minus, and this is 1.85. So I can actually go another decimal point here, 8578 meters per second. All right, so I have these two solutions here, one of which is correct, one of them is not. Now, I would suggest pausing it for a second, try to figure out which one is the correct solution and which one is not the correct solution. Do recognize that my C value here, this is the speed of the 5 kilogram mass after the collision, and D is the, velocity of the 5 kilogram mass after the collision, and this, the D here is the velocity of the 8 kilogram mass after the collision. So pause it. I'm going to take a breath here while you pause it, and then once you have a guess, come on back. All right, so assuming that you already have a guess right now, I'm hoping that you have a guess that you're taking that seriously. So recognize that the negative means it's going in the negative direction. So the 8 kilogram mass has an initial velocity of -4. So the 8 kilogram mass is going this way, the 5 kilogram mass is going this way. After the collision, in our first solution here, where D is negative and C is positive, that means that after the collision, the 5 kilogram mass is still going in the positive direction and the 8 kilogram mass is going in the negative direction, which means they somehow pass through each other. So this first solution here, right here, cannot be the case because this has, again, the 8 kilogram mass still going in the negative direction after the collision, and the 5 kilograms still going in the positive direction. That is not going to happen, especially in classical physics. Now, in quantum physics, it is possible, but this is not quantum physics. So this is the solution right here. This is positive here, which means that the 8 kilogram mass bounces backwards and the other one bounces forward. We can check it bounces, they both bounce in opposite directions. So we can check our answer just to see if it makes sense, and hopefully there's not a careless error in here somewhere, because that's a big pain to try to figure out where that mistake is. So we have 5 times, so after the collision, we are making the claim that, let's get some room here. So after the collision, we have 5 times negative 4.4762 plus 8 times 0.6726. This is the total final momentum right here, mass times velocity for each and add them together. Not what I wanted. There we go. We're back. So I have 4.4762 negative 5 times. So I get negative 22.381 plus, and then I have 8 times 0.6726, 5.381. If I add them together, I get negative 17. So we seem to be matching in momentum. Not a real shock because our momentum equation gave us this. This is the simplest one. It's the energy one that really is going to be the tricky one, or where we're more likely to have made the mistake. You know what? If there's a mistake, I'm going to reshoot this, figure out what the mistake is, and I'm going to reshoot it. So we'll erase all this stuff. So our kinetic energy final, we expect to be 60% of what we started with. So that was 0.6 times 86.4, which was 51.9. That is what I'm expecting after the collision. And so or K final, 1/2 times 5 times 4.4762 squared plus 1/2 times 8 times 0.6726 squared. Can't forget those squares there. So the first one, 4.4762 squared. So I have 50.091, and over here, 0.6726 squared times 1.810. Add them together and get 51.900. So we did not make a careless error. We have exactly what we expected. If we did make a careless error, it was in calculating that number right there. However, the math we did was absolutely spot on. Now, good news, bad news. Good news, all of this is stuff that you should be able to do. This is algebra stuff that's not complicated and just requires the concept of conservation of momentum and the idea of there's kinetic energy loss. And you know the formula for kinetic energy, the formula for momentum, mass times velocity. There are not a lot of formulas that are that simple. So so I guess that's good news. The better good news is I've never actually given a problem where you had to solve it all the way through on a test, I don't think. Maybe back when I was teaching high school years ago, back in the early days. But what I'm more apt to do is give you the problem and say, give me the two equations I need to solve. In essence, give me, you'd be working it down to this point right here. Those are the two equations that you'd be doing. It is not but going through all of that is not something that you're necessarily going to do. So just please be aware. But you should know how to go through the math, because we'll be doing math galore in the next one, because we're doing 3 different techniques for the perfectly elastic collision, and that is going to be something worth sticking around for. It is indeed as exciting as you would expect.